All right, today we're diving into a pretty radical new idea from DeepSeek AI, and it could completely change how AI looks at information. It's called DeepSeek OCR, and the whole thing is built on one simple but powerful question. What if an AI didn't have to read text, but could just see it? Just think about that for a second. You know how AIs normally read, right? They have to chop up every single sentence into these tiny little pieces called tokens. It's kind of clunky. It's slow. But what if it could just glance at a whole page as one single image and just get it, all of it, instantly? That's the huge question we're digging into, and it gets right to the heart of a major roadblock in AI today. Because here's the dirty secret about even the most powerful large language models. They really struggle with long documents. And the problem is, the computer power needed doesn't just go up a little, it explodes. If you double the length of a document, you don't double the cost, you quadruple it. It's this nasty scaling issue they call the long context problem. And trust me, it is a massive bottleneck. So you've got the old way on the left, just shoveling thousands upon thousands of these little text tokens into the model. It's super inefficient. But now check out the new idea on the right, something called optical compression. What if you could represent that same exact page of text with less than 100 vision tokens? We're talking about a massive reduction in data. This isn't a small tweak, it's a potential solution to that entire scaling problem. We've all heard that old saying, right? A picture is worth 1,000 words. Well, the team behind DeepSeek OCR basically looked at that and said, okay, challenge accepted. Let's make that literally true for an AI. And this is what they built. DeepSeek OCR. Now, let's be clear. This isn't just another app for scanning receipts. No. The paper itself calls it a frontier model. That's a fancy way of saying it was designed for one big reason: to prove that this wild idea of optical compression could actually work, that it could make LLMs dramatically faster and way more efficient. Okay, so how on earth does this even work? I mean, how do you teach an AI to read a squished picture of text instead of the text itself? This is where things get really, really clutter. And the researchers are super upfront about this. They say, look, this is a preliminary proof of concept. They're not trying to sell you a finished product just yet. What they're really doing here is testing a completely new way of thinking, this paradigm of vision text compression. And using OCR, well, it's just the perfect playground to prove that this whole concept isn't just science fiction. So let's get into the nitty-gritty. How does it actually pull this off? Well, the secret sauce is a custom piece of tech they built called the DeepEncoder. You can think of it as the core engine that makes this whole thing run. And the way it's designed is pretty slick. Let's break it down into 3 simple steps. First, imagine it has a digital magnifying glass. It scans the page really close up to see all the tiny details, like the curve of every single letter. That's step 1. Then, step 2, a super powerful compressor kicks in and shrinks all that visual data down by 16 times. And finally, step 3, it zooms all the way out to see the whole page at once, understanding the big picture, the layout, the paragraphs, the overall structure. And here's the full blueprint straight from the research paper. You can see that 3-step DeepEncoder we just talked about over on the left. It does its magic, then feeds those super compressed vision tokens into a special decoder on the right. Now, this decoder is really cool. It uses a mixture of experts approach. The best way to think about that is like having a whole team of specialists. One is an expert in tables, another is a pro at paragraphs, another one just handles headlines. They all work together to perfectly rebuild the original text. It's a really smart, elegant design. Okay, that all sounds great in theory, but does it actually work in the real world? This is where we get to the results, and honestly, they're seriously impressive. The proof, as they say, is in the data. So, just take a look at this chart from the paper. Along the bottom, you've got accuracy, how well it reads the text. Further to the right is better, and going up the side, that's the compression ratio, how much we're squishing the data. Higher up means more compression. Now, here's the crazy part. You can crank that compression way, way up, and the accuracy bar, it barely even budges. That's incredible. What does that actually mean in practice? It means this model can hit a stunning 97% accuracy even when the text is compressed by almost 10 times. So, to put that in perspective, a document that used to require maybe 1,000 text tokens can now be represented with just over 100 vision tokens, with almost no loss of information. That is a game changer. So, how does it stack up against the competition? Well, this chart tells the whole story. The vertical axis is the error rate, so lower is better, and along the bottom is how many vision tokens it's using, so further to the left is more efficient. Now, you see all those circles way over on the right? Those are the other models. They're using thousands of tokens. And then, look all the way over to the far left, that tight little cluster, that's DeepSeek OCR. It's getting the best performance while using just a tiny fraction of the tokens. It's not even a close race.
The researchers really summarize it perfectly in their paper. They say it achieves, and I'm quoting here, state-of-the-art performance among end-to-end models, enjoying the fewest vision tokens. Let's just translate that from academic speak. It means it's the best of the best, and it does it while being the most efficient. It's like winning a marathon while barely breaking a sweat.
But hold on, because it gets even better. This goes way beyond just transcribing words. The model has what the researchers call deep parsing abilities. That means it can actually understand the structure and the meaning of complex visual stuff inside a document, not just the text.
For example, get a load of this. On the left, you've got this messy financial bar chart from some report. On the right, a perfectly structured, clean data table that DeepSeek OCR pulled right out of it. It didn't just see the pixels. It understood the relationship between the bars, the labels, and the numbers to create actual usable data. That is seriously powerful. And it's not just for business documents. Look at this. Here it is, taking a complex chemical formula from a scientific paper and rendering a perfectly clean version. It demonstrates a deep understanding of specialized, non-textual information. I mean, just think about what that could do for scientific research. And on top of all that, it's also versatile enough to handle just regular photos inside a document, figuring out what they are and how they relate to the text around them. It's a true multi-talented parser.
Okay, so let's zoom back out. We've seen the tech, we've seen the amazing results, but what does this all actually mean? Why does this matter for the future of AI? Well, this is so much bigger than just a better OCR tool. What we're looking at is a potential new path to finally solve that stubborn long context problem for all LLMs. It's a blueprint for hyper-efficient systems that could chew through millions of documents. It opens up brand new eras of research into things like AI memory and forgetting. And maybe most important of all, this could be the engine we use to create the massive amounts of high-quality data needed to train the next generation of AI. This work really proves it. For an AI, a picture can literally be worth 1,000 tokens, maybe even more. It's a fundamental shift in how we think about information. And it leaves us with one kind of wild question to think about. If we just taught an AI to read in this completely new, hyper-efficient way, what other incredible, more complex stories is it about to learn how to tell?